Hi, my name's Courtney Freeberg. I am doing this presentation for a computer security course, and my teacher is Alex Hepp. This video and demonstration is for educational purposes only, and I am not liable for any damages that could be caused by these demonstrations. So today I will be presenting on what is known as DDoS. So what is it? DDoS is known as distributed denial of service. It's where you are trying to disrupt normal traffic, either on a server, a network, or service. DDoS will go over what the difference between DOS and DDoS are later on. But in DDoS, you're utilizing multiple computers. So the attack's basically like an unexpected traffic jam. It's also used as a distraction for other attacks, as it will overwhelm the network and pull the attention away from something else that they're trying to do in the system. It is a highly noticeable event, and this is why it is a good distraction tactic to try and attack other systems. It either can be in short bursts or it can be repeated long assaults. So, how does DDoS work? So, it's carried out using IoTs, and then they will use a botnet, and they could do this through malware to be able to use these other computers. And then the computers together will then be able to direct the attacks using remote instruction for each bot. And then the bot will send requests to the target IP, overwhelming it over time. So the question is, how do you identify them? The firewall can respond to them by requests coming in. There is unusual requests in the service log. There is a lot of traffic, and that'll be able to be seen in the demo of what that looks like. Or there's an unexpected surge of requests to the same endpoint, like it's come from the same computer or location, and also odd spikes in traffic during weird hours or just patterns like every 10 minutes. So there are multiple types. There is one known as the multiple vector, which is challenging to defend against because it will take more than one of the types of DDoS attack and do it all at once. There's an amplification attack, and it's where the attacker is sending out a small packet and then it's responding with a larger reply, and doing that over and over again will eventually overwhelm the system. So then there's the application layer attack. This is to target specific applications. If there is a known vulnerability, they'll want to attack that specific software. There is also the protocol attack, and this is the SYN flood. So where think of the three-way handshake, it is only doing the first part of that. And this will consume server resources and either slow it down or crash whatever resources they are attacking. Then there is the volumetric attack, and this is the most common of the attacks. It's when you're trying to flood the network with traffic. So let's go over what the difference between DOS and DDoS is. So DDoS, you're using multiple devices, and it can either be multi-person or obviously multi-device, as I said before. And they're going to use botnets to do this. And they are trying to look for network infrastructure versus just flooding a target. DOS is using a single internet connection, it is trying to exploit software or flood the target. And you'll be able to see in the demo, I conduct a DOS attack, but if those were on a larger scale, it would be considered a DDoS attack. If the demo is used by multiple computers all at the same time, then it's considered DDoS. So there are some famous examples that DDoSes are happening, and they're becoming more prevalent, and the requests per second are increasing. So let's talk about Google Cloud in 2022. It was the largest attack in 2022. It was directed at the Google Cloud customers to not be able to access the applications. 46 million requests per second was like the overall peak of this. It began with 10,000 requests per second. And then after about 8 minutes, it was reaching about 100K requests per second. And then it peaked overall at 46 million. And then Google Cloud was actually attacked also in 2023, as I could find. And at that point, they reached a peak of 398 million requests per second. That's what this graph is from. It's from the attack of 2023. So there's another example. Amazon Web Services was attacked in 2020, and they recorded about 2.3 terabytes per second, which is the largest I could find. It lasted 3 days. It was known as connectionless, lightweight directory access protocol reflection-based attack. And basically, it requested to a server with a spoofed sender IP address, so they couldn't see where it was coming from. The server mounts a bulk up response to the target's IP address, causing a reflection attack. So one thing we should be talking about is mitigation and how can we fight against these attacks? There is something known as black hole routing. It's where you funnel the traffic with the help of the ISP. But the problem with this is it will take good and bad traffic. So it's kind of doing what the attacker wanted, is where they wanted to crash the system, and if you're taking the good traffic and putting it into this black hole routing, it's not getting there anyways. So another one is rate limiting, which is the number of requests a server will accept. There's the web application firewall and network diffusion. So to continue on with prevention and preparation for something like this, a DDoS response plan is always a good thing to have if this does happen, and the team will know how to respond. Data backups are also a good thing to have. There are anti-DDoS services such as Cloudflare does them. There's also a thing called employing content delivery networks. It distributes the content across multiple dedicated servers, so not one is overwhelmed. Also, as a team, monitoring traffic regularly is also one good thing, to have alerts go off for the team to be able to respond, even if it is a false positive. It's good to look into. Keeping the systems updated is also a good one because it prevents vulnerabilities that have been found and are known. And also staff training is another one. So they should have a response plan. They should know how to respond, how to report it, and how to prevent it in the future. So there are some network security measures as well, such as an IDS, which is a detective system, which is what would raise alerts, but also firewall configurations. So for the demo, I will be using hping3, and I just wanted to go over quickly why I would be using this. And this will be considered a DOS attack and not a DDoS. But as I said before, to be considered a DDoS, it would be me using multiple VMs to attack the one. So if there was multiple computers involved, then it would be considered DDoS. So hping3 is normally a network tool able to send custom packets, and it can be used in Kali Linux. It handles fragmentation, packet body, and size, and that'll be able to be seen in the demo. You can use this to test firewall rules, port scanning. This can be used to test your network performance, attack through packet crafting, and these can do like the SYN flood attack is one of the attacks that is used during this. So now that we overall talked about what DDoS is, what DOS is, kind of what hping3 is, and the strategies to prevent something like this, here is a demo. So to start off with our DDoS demo, we're going to be using Kali and Windows 10. Kali will be our attack machine, and Windows 10 will be our target machine. This is all going through VirtualBox, and these are both VMs running. One thing to start off with is we will be going to command prompt, and we will go and do ipconfig, and this will help us find our IP address for our target machine. And then from there, we'll go over to Kali and do a similar thing with ifconfig to also find that IP of the attack machine. And here you can see is our IP. And then from there, we're going to make sure the machines are communicating with each other. So we are going to ping each side to make sure there are some sort of packets that can come through. So as we can see, Kali is able to see Windows 10. And then we will go also do it on the Windows side and ping Kali from there to make sure Windows can see Kali. And then we're able to see that it is sending packets through. So we'll be using Nmap here, and Nmap will help us look for the open ports on the Windows. And for this example, we will be using port 135, which is open according to Nmap. And on the Windows, we will try and pull up Performance Monitor that will help us kind of see the overall usage of the machine. So I'll try to minimize this, and then we'll also pull up Wireshark to see what packets are coming through. This will overall help us determine if things are actually working. So now we're going to go through our actual attack. So sudo is giving us permission to do this. hping3 is what we're using to attack. -s, and with our attack IP of Kali, and then -a and our IP of Windows. This is our target IP, and then the port that the -p 135 will then be the open port we're trying to send this through. And then flood, it will try to send packets as fast as possible. And if you look on our performance monitor, everything looks normal. So then let's send through the attack. And you can see it getting flooded. And in the performance monitor, you can see that it's spiking as well. So in this, you'll see as well, you can tell what source it is coming from is that is the IP for Kali. And you can also go into like internet protocols and go down to the source and it will show this as well. As we can see that it is indeed coming from the Kali machine. Then let's say you want to do an attack where you don't want them to be able to see your IP address. Let's do sudo, which gives us our permission, hping3, which is our attack. And then this time we're going to do -c and then a number, which will be the number of packets we can send. And then -d is the data size of each packet in bytes. And then -s will do our SYN flag, our port number, flood it, and this time it'll be random source. And this will help us kind of mask the IP of Kali. And then we're going to put in our target machine, which is the Windows, and then send it through. And then this time you're going to notice, if you look obviously in the performance monitor, it is skyrocketing again and it is sending packets through as fast as it can. But this time it is sending them at a certain size and byte-wise as well. And as you can see in the source, it's constantly randomizing it every couple packets. So this time you won't be able to see where it exactly is coming from. And if you click on one of them, you can obviously see the attack is stopped and everything is slowing down. And as you can see, each and every source is kind of randomizing as it goes. So this helps mask the Kali machine or where it's coming from. So the last attack we'll do is a LAN attack. This is where we are going to have the target machine the same for the attack. The Windows the same for the attack and the target. And so we're going to set our flag with the -s and then our Windows IP and then -a in our Windows IP. And then we are going to do -k, which enables fragmentations of packets. And then -s is our source port number, which is 135, and our port number 135, and we are going to flood it. And then as this goes through, you're going to see skyrocketing again. On the performance monitor, you're going to see tons of packets coming through. And with this attack, if you have multiple computers obviously coming in at once, that will possibly freeze and crash the computer. In this attack, it's kind of its overall what they're trying to do with a DDoS attack. So then we're going to try something a little different. We're going to send that same command through, but this time I restart the VM and turn down the CPU a bit to see if we could either slow this down or crash the VM. And overall, it should overwhelm it and slow it down. But in a DDoS attack, normally multiple computers are attacking a source, and so it probably will crash it and or slow it down with the number of packets each and every computer can send through. And as you can already see that even with the VM normally running, with the CPU turned down quite a bit, that it is already in a quite high utilization. So for this, we're going to send through the that code, the last LAN attack code that we sent through, and we are going to try and slow this thing down and or crash it. And as you can see, the utilization goes all the way up to 100 right off the bat, and the packets are going through. It did slow down the machine a little bit, but if you have these VMs, a Kali and a Windows one, you can also try these just to test it out and kind of play with the settings of overall like the CPU usage and try this to freeze up the machine. And overall, that is just some ways that DDoS attacks are done. Now that the demo is finished, these are just some ways that DDoS can happen. And here are my citations. Thank you for watching.